Town Rock Energy. The last time, actually, I did a talk in front of this number of people. My speech began with, on behalf of my wife and I. So this is a little bit different. But I suppose without further ado, on behalf of my project partners and I, thank you for your attending, and to the organisers for giving us the opportunity to give this presentation to you all today. It's great to be here in person. So this afternoon I will be presenting an update on the Galleries to Calories research project. Galleries to Calories is funded by Geothermal. It's a research project with a duration of 3 years. It began in September 2022. It's very much a multidisciplinary research project with an international research consortia consisting of project partners from academia, from industry and the public sector, with project partners from the UK, the US and Ireland. The aim of Galleries to Calories is to investigate the feasibility of developing a geobattery system. And by geobattery, what we mean is the use of the subsurface as a means of storing and transporting waste heat from an industrial process, not only providing cooling to that industrial process, but using the waste heat to supplement the natural geothermal resource, in this case in flooded mine workings, with the potential extraction of the heat downstream via boreholes in a heat network to supply heat to end users. It's worth saying that the Galleries to Calories project, the intention is not to build such a system just now, but investigates the feasibility and determining kind of best practice guidelines as to how you may go about doing this. We've taken a very much holistic, multidisciplinary approach to investigating the feasibility of a geobattery system. There's a series of work packages in the projects, ranging from environmental and geoscientific site characterisation, the development of a field test site through the drilling of abstraction, reinjection and monitoring boreholes, with hydraulic and tracer testing, and a series of sophisticated modelling orientated work packages which will focus on the mechanisms of heat transport and fluid flow in the subsurface, as well as also considerations of community and stakeholder engagement and techno-economic analysis that will inform the development of such systems. So as you may appreciate, there's I could probably speak for an hour on this project, but obviously limited to time constraints here. So there's a bit of a whistle-stop tour of the research which has been done to date. So the location for our study area is the University of Edinburgh's Easter Bush campus, which lies to the south of Edinburgh. Within this campus, there is a data centre named the Advanced Computing Facility, which has, at the moment, a waste heat resource of about 3 to 9 megawatts. We know this area of southern Edinburgh is underlain extensively by mine workings associated with the Roslin, Ramsey and Burley collieries. And downstream of the data centre, we have a number of communities like Lone End, Strayton, Bilston, where there's a number of kind of opportunities for domestic and commercial use of low carbon heating. So that's the kind of context and the premise of what the research is based upon. The project really kind of began with the development of a conceptual model of our understanding of the geology of this area of Edinburgh and the hydrogeology. This was based upon analysis of local geological data and kind of detailed analysis of mine abandonment plans for the associated collieries. The key takeaway points from the conceptual model are that each set of mine workings are conceptually similar, but there are some kind of distinctions. So we know that there are locally kind of through connections between all three collieries. We know that Roslin mined up to and through a regional fault. Burley crossed local water courses. Ramsey worked through local faults. So as well as the architecture of the mine workings themselves, we know that faults are likely to exert control on the capability of heat and fluid flow in the subsurface. Informed by the conceptual model, one of the important aspects of the project is to conduct environmental baseline monitoring. This is really a precursor to drilling and hydraulic testing activities, so that we kind of establish what the surface water quality is of local water courses, so that we can judge whether the drilling and testing activities have an impact on the surface water quality. So we've conducted an extensive baseline monitoring campaign since June of last year. We sample 38 different locations on local water courses from Bilston Burn to the Kilburn to Glencorse Burn, and then the North and South Esk. The programme and the locations of where we conduct the sampling, it's kind of important to note these were decided based upon the location of known historic shafts and adits related to the mine workings. So we sampled upstream and downstream of these locations. And just in terms of the data that we're collecting suites of physical and geochemical data, such as temperature, pH, conductivity, ORP, TDS, and major anions and cations through water sampling. So yeah, there are some photographs of us in the wild doing the sampling, and we're planning to continue the fieldwork campaign through the remainder of this year and beyond, but particularly increase the kind of density of our field visits during the drilling and testing activities. This is just a snapshot of the data that we're collecting. So we're assessing the data on a kind of temporal basis to judge kind of seasonal variations in the data, but also on a geographic spread. So we're covering a fair area of this of the kind of south east of Edinburgh. Another important aspect of the work that we've done, again informed by the initial conceptual modelling, is the development of a detailed 3D geometrical model of the subsurface and the architecture of the mine workings. This work was led by our colleagues at University College Dublin and University of Edinburgh, who have developed these models based on mine abandonment plans and what is known of the kind of local geological structure. These 3D geometrical models have been utilised to model the kind of thermal and fluid flow transport mechanisms in the subsurface. I won't dwell too much upon this slide because my colleague Ali's presenting on this tomorrow, I believe. But it's just worth saying that the models were developed using FeeFlow and Leapfrog. And the model, the kind of extent of the thermal plume from our planned injection wells kind of downstream towards the aforementioned communities, kind of downstream of the geobattery site. And so through the project, we've developed a really quite sound understanding of we think the behaviour of the subsurface might be, and developed kind of sophisticated models to simulate this. The real interesting point of the project is to drill abstraction, re-injection and monitoring wells into these mine workings and conduct hydraulic and tracer tests to verify the results that we're getting from the model simulations. So our plan is to conduct these drilling activities in this summer, and then also spend the remainder of the project duration comparing the results of these tests with our model simulations. And this is a summary of the timeline for the remainder of the project duration. So we'll be looking to issue a tender for drilling next month, and then begin drilling in the summertime, with completion sometime kind of late August, hopefully. After which we conduct the hydraulic testing, and then bring everything together in the feasibility study report, which will outline, as well as everything I've talked about today, best practice guidelines when it comes to community engagement, heat ownership, technical economic modelling, and all the kind of other aspects of the project which I've not really had time to chat about today. So yeah, just in summary, we've developed a really sound conceptual understanding of the hydrogeology and the geology of this area of Edinburgh through developing kind of complex models. We've simulated fluid flow and heat transport through the mine workings. We are collecting an abundance of baseline monitoring data to characterise the surface water quality, which will be further assessed when before and after the drilling activities. And we do plan to drill abstraction, reinjection and monitoring boreholes, and then conduct the tests this summer. So lots of interesting research coming up. It'd be remiss of me not to acknowledge the contributions of all my project partners, specifically Chris McDermott, Sam Graham, Alejandro, Pablo and Mike for their contributions to these slides. So thank you all. And thank you for listening. Welcome any questions.